Hello and welcome to a small tutorial on drawing Newman projections for chair conformations of cyclohexane. So if you remember, we talked a little bit about cyclohexane. There we are, that's a nice cyclohexane. And how cyclohexane has 12 hydrogens. But we also talked about how this is kind of an unrealistic representation of what cyclohexane actually looks like, right? Because cyclohexane exists in the chair conformation, typically, or at least it's the most stable conformation it can exist in. There we are. That's a nice chair. And the hydrogens around the chair are in different positions depending on whether they are axial or perpendicular to the seat carbon-carbon bonds, or whether they are equatorial or parallel with those highlighted carbon-carbon bonds that make up the seat of the chair. Okay, and we talked a little more in section, I believe that was 4.11. Maybe it's 4.10. 4.10 or 11 about how in cyclohexane chair conformations, you can also draw Newman projections. So if we had, for instance, CH3 group here, we could draw a Newman projection where we're looking at both this carbon and this carbon at the same time. Where instead of just having one hidden bond, now we have two. And our Newman projection, we said, would look a lot like this. So we have this going down here, and then in the back, we would see this like that. And since the CH3 is pointed up in our Newman projection, it would also be pointed up here because it was axial. And we have this as the hydrogen here, here, and the two front hydrogens and the two back hydrogens there. So hopefully you see where that came from. And if you don't, I have a model kit that hopefully will help show this a little easier. So here is a molecular model kit I have of the chair conformation. And you can see that I have also included our Newman projection carbons. The one on the right here, that one will be the one with our CH3, and the other one will be the one just with our H's, okay? So in the Newman projection, remember we were aligning our eye such that we could see this carbon and this carbon at the same time. So let's do that. So we'll just line up these carbons here. Hopefully this works. Okay, that's about as good as we can do here, I think. There we go. So now, hopefully you can see that that carbon that was axial is now pointed straight up. And we see the front carbon, the one that I'm holding on to, it does in fact go down between the two carbons we're looking at in our Newman projection. And in the back, that carbon is sticking up. So this has been the small tutorial on Newman projections for cyclohexane chair conformations.